to college website, you find departments. In departments, you find computer science and engineering. There you find faculty and staff. If you click that, you will get this, right? In that, you can find my name, Muhammad Abdul Azim. If you click this, you will get my profile here, okay, like this. And here you can find my YouTube channel. If you click this YouTube channel, you can find all my, lectures recorded, being edited, posted on this YouTube. So you can rather, listen all these recorded lectures, okay. For all the 21 classes that is happened so far, which covers the first 2 units, of which all recorded lectures are available in this YouTube. You can subscribe it. You just go and there is a subscribe button. You can find at the right, this subscribe button. You will be notified with all my new lectures whenever I upload, so that you can probably watch it in your free time, okay. Fine. And material, regarding material and all, you can go to my blogger. If you just click on this blogger, the blog or come website, this is my college, this is my website. So if you go to my website, you can find the material of all the subjects. Rather PPL also you can find here. You can find at the bottom PPL lecture notes. If you click on PPL lecture notes, you can find the assignment 1 posted for 2020-21. You can just click on download and you can download it. 2019-20 also is there anyway. Syllabus is also available, lecture notes with PPTs and the entire book. The syllabus is prescribed with the Robert W. Sabasta, right? So this is your reference book, and of which PDF is available here. If you just click on, you will get the entire ebook of the same. Okay, and then important questions are also uploaded here for the external point of view. From the external point of view, from all 5 units, what are the important questions are available, you can download from here. So this is my college web, my own website. So my website where you can probably find this material. This is my YouTube channel. This is my website. Okay, these are remaining other my accounts, right? Twitter and Facebook. And if you want to communicate through the we have Google Scholar or ResearchGate and all kind of thing. When you're probably doing some projects and all, you can probably communicate with the other accounts. So you can make use of this material available on my YouTube, on my website. All my detailed lectures available in my YouTube. So you can probably go to my YouTube channel, subscribe it, and listen all these videos, topic wise available. This is control statement. This is names, variables, binding, and all. This is reference type. This is pointer data type. Similarly, for each lecture, recorded, edited, one available on my YouTube channel. Arrays, records, and this is grammar, ambiguous, unambiguous grammar. This is primitive, non-primitive data type, and this is about the introduction to data types, review on programming languages. This is the entire Unit 1 review class, and this is semantic and attribute grammar. I have discussed probably operator precedence and associativity rules were discussed in this lecture. Past trees, how to construct the past trees using the BNF grammar, and how to convert BNF into BNF grammar, and ambiguous, unambiguous grammars are also discussed in this again. Grammar definition, derivations, leftmost, rightmost derivations are discussed here. Then syntax and semantics, how to define the syntax for the programming constructs, and what is the semantic, how does the semantic basically explain to the computer, with the help of operational or denotational or dynamic or static semantics. All that have been discussed here. Then concepts of programming languages, then introduction to programming languages. Then you have programming and environment. What are the different environments you have, and how do you execute the programs using the different kind of environments? What the environment will help you in providing the facilities with which you can probably rather execute your programs. And you have language categories and implementation, different kind of language. I mean, the classification of languages based on the language paradigm. Okay, programming paradigm, and their implementation. There are different kind of implementation like compilation, interpretation, and hybrid implementation. All that were been discussed here. And then this is about data structure. This is my introduction to data structure. Actually, it's not required, but the remaining there are about 21 lectures here you can find, which covers the entire 2 units of the programming language syllabus. Okay, so if you want me to just first go through the syllabus, I will uh, uh, take a look at the syllabus. This is your programming languages, syllabus as per the AICTE model curriculum. This is from 2019 and 20. Okay. The course outcomes here at the end of the course, what is that you're going to learn out of it are ability to express syntax and semantics in formal notation, ability to apply suitable programming paradigms for the application, gain knowledge for and comparison of the features programming language. Anyway, we have defined our own course outcomes as well. This is defined by the university. I will discuss about our department course outcomes as well, of course, right? And preliminary concepts here. The first unit covers the preliminary concepts, consisting of reasons for studying concepts of programming language, programming domains, language evaluation criteria, influences on language design, language categories, programming paradigms like imperative, object-oriented, functional programming, logical programming, then programming language implementations, different kind of implementation of the programming like compilation, interpretation, okay, compilation and virtual machines, then programming environments, all these are discussed. Then syntax and semantics also is being covered as part of the first unit. So here we're going to discuss about the syntax. Every statement in the program to be defined with the help of some kind of syntax. Syntax is a set of rules that govern whether a sentence is well formed or not, right? And the way in which this particular sentence will be understood by the computer is said to be the semantics. That is also required to be made clear by the program language designer, right? So language designers have to make these things clear to the computer while they are designing the programming language. So how does they do with the help of grammar, right? So there are two different type of grammars available. Like we have BNF grammar, Baker's norm form, invented by John Baker's, and we have Chomsky norm form by Chomsky, but widely used is the BNF, Baker's norm form. So using BNF, how do you define the grammar for the different statements? So are being discussed here, right? And then the compact form of the same is being represented with the help of eBNF, extended BNF. In eBNF, we can probably rather compress the statements of the BNF so that it can be represented with less number of statements. So using this grammar, you generally define the syntax of the programming constructs. Then what happens in compilation implementation after the syntax analysis is done, then a parse tree is going to be generated, right? So what is a parse tree? Parse tree basically consists of basically the tree consists of a root and then subsequently its children. So similarly, you will have terminals and non-terminals in the grammar. So your first non-terminal is said to be the root here in the parse tree, and then subsequently you will have non-terminals and terminals as their children. So eventually it leads until the leaves. Leaves are said to be the terminals rather, right? So terminal in the sense which is an atomic unit cannot be further divided. Non-terminal is the one which can be further divided, right? So generally you find these two kind of elements, terminals and non-terminals in the grammar. So the same is being represented with the help of a parse tree. So parse tree is the other way around, I can say, is a pictorial representation of the grammar, right? So the grammar is going to be converted when it is being analyzed with the help of a parse tree, and then the parse tree is going to be taken for to the computer, which can be rather interpreted on the machine with its meaning. It's set up with the semantic. So before it is being done, it checks whether the grammar is ambiguous or ambiguous. So when you say a grammar is ambiguous, when a statement can be, when you can be able to construct more than one positive for the same statement using the grammar is tend to be the ambiguous grammar. To carry some kind of data, it stores some data. I mean, you will be storing some data. And so ultimately, there is some data available in the computer. So what a program basically does, program is a set of instructions which carry out certain tasks. And these instructions are going to be carried out on the data itself, rather, right? So if you look at the program or you look at the computer, right? So if you look at the computer, everything is a system, rather, right? Computer is also a system. Computer is a system which takes inputs and produces you the output, right? What kind of inputs does the computer takes? It takes two set of inputs. One is the program, another one is the data, right? So data is the input, and program is also another input, rather, right? So the program is going to be carried out or executed on the given data, and then it produces some kind of output, and the output is again some kind of data. Okay, so input is the data in program, and the output is the data itself, rather, right? So the data, I mean, after all, if you look at in the computer from the right from the beginning till the end, it requires some data. It takes some data, it processes on the data and produces some data, rather, right? So ultimately, there is some data, right, without which you don't do anything in the computer, rather, right? So in the programming languages, when you study, basically there are two certain things which you probably look at, before you start programming languages, or when you probably start learning the programming languages, you look at these. So here, data types. What do you mean by data type? Data type is a set of collection of objects. You can say it's a set of collection of objects, or a set of collection of elements, or set of collection of events. Okay, you can say, and the set of operations performed over them. Okay, the second definition, if you miss, then the definition of the data type will be missed. I have divided the definition of data type into two parts. The first part is a set of collection of objects, I said, right? A set of collection of elements. And the second part of the same, I said, set of operations performed over the same. It means here the programming language designer, while he is offering that different kind of data types to the programmer, he must have to define and make the operations clear for the data type, for the respective data over a long time, rather, over a particular duration, rather, right? So we're going to discuss about the same here in unit 2. The arrays, pointers, what are the different design issues. When you probably say, for example, if you're designing a language, then if you want to include arrays, what kind of mechanisms you need to adopt in order to access the elements of the array. Right? Because array is said to be the set of homogeneous elements are going to be stored in the contiguous locations, and what kind of operations that you can perform on arrays. These all comes under design issues. So we'll discuss about the design issues of the different data types when we study the data types, and then what kind of operations that are allowed upon it, and how they can be rather used, implemented, what are its advantages, disadvantages, how they are being implemented in different kind of programming languages. All that you're going to discuss in the data type chapter, rather, right? Then coming to, we have naming, name a variable, and type binding and all things, right? So when you want to implement, let us say, for example, some operation. For example, you want to perform addition operation. How do you perform saying C equal to A plus B, right? Saying you know that what is the range, then you can probably use that variable in its proper way, right? So while this is all said to be the syntax, right? The semantics of the programming language. So while before you use the programming language, you must have to know the syntax and semantics of the programming language, rather, right? So these are three things you must have been known before rather, right? When you studied C, C++, Java, that when you declare a variable, that variable will have a name, it will be allocated with some kind of memory, because every variable is being defined with certain data type, and data type will define as how much data, how many bytes of memory being required to be allocated, which is specified by the language designer. And the range of values that you can have for the particular variable is also been specified by the language designer. So 3 attributes of a variable, you may say that one is the name, second one is the memory, third one is the the memory or the address, I say, right? Because memory is going to be represented or accessed through the address, because every memory will have some unique address. Every byte of the memory will have a unique address, right? So this address only will help you to access that particular memory, rather, right? So I can say memory. Intermittently, I can use address also for memory, rather, right? So another third attribute we say is a value. So these 3 you have already known about, but in addition to these 3, I am now introducing 3 more here in this particular chapter, right? One is the lifetime, another one is the scope, another one is the type, right? Type. Here, the variable, now I can say not 3 attributes will have, it will have 6 attributes, okay? It will have 6 attributes. One is the name, another one is the address of memory, third one is the value, the next is lifetime, scope, and then type, okay? So here type means what could be the type of the variable, rather, right? Whether it is integer, character, float, long, double, okay? And then there is a scope. Scope is the sense the part of the text in which a variable is accessible is said to be the scope, okay? So, and then lifetime. Lifetime is the amount of time for which the memory being allocated for the particular variable is being binded, okay, over the execution is said to be the lifetime, because lifetime is going to be changed for the variables unless it is a static variable. You must have studied about static variables before, right? Static variables in C, C++, and Java. Static variables lifetime is constant over the entire execution, but for the non-static variable it is not the case, right? It means the memory which has been allocated to a variable over the execution, over the same execution I'm talking about, over the same execution, when the memory being allocated for a particular variable is not going to be retained for the entire execution. Integer variable with the character variable. Will it be allowed? It should not be allowed. Then how does the programming languages will fix this problem? Right, to be solved. In C language, you have type coercion mechanism, right? Type coercion. What is type coercion? Implicit typecasting. Okay, implicit typecasting. Generally, most of the programming language designers will adopt either implicit typecasting or explicit, right? Implicit or so. What happens? This float will be converted into integer and then will be added to this variable, and the result will be produced as integer, right? But in Java, you have explicit typecasting. In that, what happens? You will have to explicitly cast this variable, right? So this b has to be converted into integer like this, and then will be added. Well, this you do it. But in C++, this will be automatically taken care because we have implicit type coercion, right? Be done as part of the language designer only. The language designer must have to take care of this, right? So type checking, and then strong typing. What do you mean by strong typing? Basically, in C language, as I said, since you have implicit type checking, typecasting, then it is taking care of allowing the operations if the type of the variables are different. But whereas in Java, if I have, let us say, for example, C equal to A plus B, where A is integer and B is float, and I don't have the typecasting done in the programming language, then this particular statement will be prevented from being executed, rather, right? It will not be rather executed. Okay, what a point. So because in Java is a compiled and interpreted language. It is a hybrid implementation kind. Okay. What happens in Java? First, the program which you save it with the help of .java extension, okay, will be compiled. When it is compiled, okay, it generates the .class files or the UBC, universal bytecodes, which can be rather then interpreted on virtual machines. Java virtual machines, interpreter we call it as, right, or JRE, right? you will find JVM or JRE inbuilt with all browsers and operating systems. So this is even said to be the interpreter. So now these UBCs are going to be interpreted on this machine line by line. So at the time of execution, right? This is the execution, right? So at the time of execution, again, every line is being checked here, right, by the interpreter. So you have two-time checking, you can say. Here, the compiler is checking once, right? Compiler is checking once to ensure that the syntax is correct or not. Again, during the execution, the interpreter is checking. So you find two-time checking. That is the reason why we call this kind of languages are said to be the strong typing languages, right? Ada, Java, these kind of languages are said to be strong typing, whereas C, C++ are said to be the loosely coupled or weakly typed, because only at the time of compilation the code will be checked. For the execution, what happens? The entire code will be sent for the execution at once, right? In compiled languages, what happens? In compiled languages, after the compilation is done, you get the object code generated, right? Object code generated. The entire code is going to be sent to the machine at once, right? So during the execution, you don't have any checking kind of thing. So if you have such kind of statement which can be resulted only during the execution, which will not be rather checked. That's the reason why it is taken care with the help of implicit and all kind of thing. Anyway. Fine, that's how it has fixed the solution. But the other way around, if I see from the programming construct point of view, I can say C, C++ are weakly typed, and Java is strongly typed, because you have two-time checking. And if you have certain statements of this kind where you do not have the explicit type binding also being made available, then that statements will be prevented from being executed by the interpreter during the execution. Okay, and it raises an exception. Exception raised or error raised during the runtime is to be exception. So this is said to be the strong typing. Probably if you watch my videos, you understand it better with the help of examples. It's all being explained. So type compatibility as well. These all follows the same thing. So how does you make the type to be compatible with each other? By either converting, right, from one to another rather, right? So that can be done with the help of explicit or implicit type conversion, right? The name constant, all these all then you have control structures. Control structures includes the conditional and unconditional statements, right? Conditional, like you have if statement, if else statement, right? And first statement, while statement, do while statement. This is that which you have studied as part of C language, right? These are some of the conditional statements you have studied as part of C language. And unconditional statements, unconditional, like you have studied go to, break, continue. These are some of the unconditional statements that you have studied. All together is said to be the control statement, right? So one statement under the control statement, I can say switch case or the case control structure. Switch case consists of both conditional and conditional, right? If you look at the syntax of switch case, you find switch expression, then you find case, you find here expression value 1, right? Like that, and then you have some statement to be executed, then you have break and all, right? So you can find break is unconditional, and here you're checking the condition, right? This expression which has been evaluated before is going to be compared across all these cases, and which has been found to be true. Only then you are going to execute the respective blocks of associated, followed by these cases, and then you will break, so that you can come out of the loop by executing only that block, skipping the remaining blocks, right? So if you look at the syntax of switch case, which is is a combination of condition and condition, I can say rather, right? So these are all going to be discussed as part of the control structure. So this is all available in my YouTube channel. So all of you, I request all of you to subscribe my channel, watch the videos, and try to understand them. Probably if you do not understand, yes, we can probably again have some kind of review classes for the same. So what I request from my side for now, all these 2 units lecture videos are available here. Okay. So what is that you're going to do is, you're going to first subscribe the channel and then listen all these videos. First you complete the first unit. Okay, after you complete the first unit, um, we will have a discussion on the first unit. Okay, so if you can finish both the 2 units by today, in tomorrow's class I can discuss rather 2 units, but I don't think it is possible for you. So what I do, I mean, I request all of you to listen all the first unit videos from this YouTube channel, and then we will have a interactive session tomorrow discussing the questions of the first unit, right? So first unit questions I have posted here, so we can discuss these first unit questions, okay, tomorrow in tomorrow's class. Right. So under this unit 1, I have mentioned some 22 under short questions and around 12 under long, right? So we can discuss all this, and combining all these two also available here. Okay, that is PL assignment 1 2021. This carries both the first and second unit. Okay, this carries first and second unit. So let us now look at this assignment questions of few. Today we'll discuss, we have about 10-15 minutes time left for our class to finish. So I'll discuss some of these questions, and I think most of you may are aware of these questions before as well, since you are from the polytechnic background. You can answer the questions for the same, okay, and otherwise I will give you the answers for the same. Okay, now if any queries, please you can unmute your audio and then speak up. Left, so you can answer some of the questions which if you are familiar with, rather, right? What programming language has dominated scientific computing over the past 40 years? Anybody from your class? We have a lot of languages available, right? We have Fortran, Pascal, Ada, Elgar, Prolog, Lisp, PL by 1 to 60. Then we have APL. We have what do you call Lisp, ML, Haskell, Python. We have PHP. We have all scripting languages like JavaScript, VBScript, Shell script, Bourne shell, Conch shell, and we have Java, C hash. A lot of languages. I mean, we have divided from the programming paradigm point of view into 4 kinds, right? If you listen that video, you can probably get to know about it. Imperative programming languages, functional programming languages, object-oriented programming languages. Then we find logical programming language. These are the 4 paradigms initially we thought of. Then of course we got now concurrent programming, also a new kind of programming languages came into being, right? So scientific domain, initially if you look at basically you may have, when you learn about C language, you may have learned that before C language all languages were application specific. What do you mean by application specific? Languages were available with respect to application. For example, you have scientific or engineering application, there is a language called Fortran, formula translation language, right? So Fortran being used for what do you call for engineering and scientific applications, FORTRAN, formula translation. So this was being used, for scientific applications before C came into being. If you look at the history behind C invention, right? Who has invented C? Dennis Ritchie, right? Dennis Ritchie, he has invented it in 1972. Okay, Dennis Ritchie in 1972 at Bell Labs. Of course, it was being given as an assignment, but he has developed out of his own interest, right? By adding a lot of features which was not there before C, of course, right? And another main, reason behind inventing C and the main application are the main, what do you call the feature, the other way around. I say it is applicable for all kind of application. This was the main reason behind going for this, implementing this C language, all kind of application. Actually, what happened, in around 1970s, DARPA is said to be the Defense American Research Project Agency. Now they have called different teams of, from different domains. AT&T is one of the domain. Basically, it's a telecommunication domain. So where Dennis Ritchie was working, of course. So a lot of teams were being separately, appointed, and then they were all told to come up with a language which can be applicable for all kind of applications, right? Then some languages came into being in this, scenario. One is Combined Programming Language, CPL by Martin Richards, and BCPL, Basic Combined Programming Language. Then B by Ken Thompson. Of course, Algol and Lisp and all also came into being. But immediately after B came into C being, right? After B came, C came into being, right? So C is developed by Dennis Ritchie. There is no abbreviation for C. And most of you may think that there is abbreviation for C. C stands for something. C stands for nothing. C has been invented after B, so the language name is given as C actually. Because in alphabetical, in English alphabet, you find the alphabetical order is A, B, C. So before C, actually B was developed or invented by Ken Thompson, right? Ken Thompson. Then C is invented by Dennis Ritchie. Since after B it came, so he has named his language after C, right? That is the only reason. There is no abbreviation for C. C stands for nothing, okay? So, but then if you look at, there were some drawbacks associated with this CPL, BCPL, and B languages. But then all that disadvantages have been overcome, and this language came into being with the same kind of motto behind. That is to implement it for all kind of application. That was the main reason behind implementing this language, right? Before C, there were languages available, application specific. As I said, Fortran for engineering and scientific, Pascal for avionic application, right? Pascal for avionic application. Avionic means airplane and airplane traffic to maintain and all kind of thing, right? Then you had COBOL for business applications, right? COBOL for business. COBOL is the first high-level language. You must be knowing, rather, right? There is a difference between high level and low level. What is the difference between high level and low level? One of you can raise the answer.
High-level language can be understandable by humans.
Yes. So basically, before high level, if you look at, the languages were machine languages only, machine understandable, because computers were being used, by either the academicians at the universities or by scientists at the defense or, military agencies of the America. So where, of course, all these people will well aware of the machine structure, so they don't have a problem in programming the machine language. So that was fine working with machine language. But then when people thought that computers should be brought into the market, right? It should be brought into the market, and it should be made available to every user. I mean, the person who may not know the computer and computer languages also should be able to use that computer. I mean, novice user. Fine. Novice means the person who does not know about computer, rather, right? So such kind of users also should be able to use. Fine. Because in market, in business, in commercial, uh, you know, uh, things, right, where probably user will use his own language. For example, in America, British people use their language like English, right? English their language, native language, right? So we should make the programming language available in native languages like English kind of thing. Fine. So in order to make this possible, then the high level languages concept scenario came into being, right? So this when the user is writing the program in English, then to make the computer to understand in machine, right, machine language, you must have some kind of translator in between, right? You must have translator in between. So what is the translator? Translator could be compiler or interpreter, right? Based on the kind of implementation, the kind of translators are being used, right? So you can see user will write the program in his native language like English, then they are going to be rather converted by the translator and then will be interpretable on the machine in the machine form, right? Machine understandable form. Okay, so this is all of course happened. Fine. After the high level language came into being, first high level language came into market is the COBOL, Common Business Oriented Language, which is being used for the business application. Then, of course, later, a lot of other languages came into being, and the history behind C is to make it applicable for all kind of application. This was this main, motive behind. So, like you have different applications, no? You have education application, you have commercial, you have unique, you have military application, you have defense application, you have, scientific applications, you have automated, automation application, you have networking, domain, you have communication domain. So in the artificial intelligence domain, you have long range for the weather forecasting domain. All these kind of domains you find, right? High computing domain. So for all such kind of domains, a language should be available. That was the main motto behind inventing the C language, and it was found with good features, offering very good features before. That there was no languages who have offered that, because of which it has got very good popularity within very less time, and it has ruled above a decade until the object-oriented programming scenario came into being in 1985. George Strauss-Trapp, right? George Strauss-Trapp has come up with C++, right? C++ is not the first object-oriented programming language. Rather, Smalltalk is the first first object-oriented programming. Most of you do not know about it, rather, right? And most of you do not know there is a language called AICTE, named after a lady who is the first programmer of the world, right? Who is the niece of Charles Babbage, right? Who is Charles Babbage?
Inventor of computer.
Yes, inventor of the computer, father of the computer is, right? What is the name of the computer he has invented? Abacus, right? So Abacus was invented by Charles Babbage, and the first lady who wrote a program on it is the AICTE. And named after her, a language is still available. Most of you do not know. This is not that popular, but this is more powerful. It's a very powerful language. Fine. Basically, air traffic, if you see missile traffic, where it's a real-time application, right? Because time is more important. Micro, nanosecond is also important. Petasecond is also important, right? Within that nanosecond, if anything happens, then this mission will completely collapse, right? So the decisions have to be taken and programmed well, in order to keep the missile or air or such kind of real-time systems to work in more appropriate manner. So in such kind of situations, you use a more powerful language like ADA kind of thing, right? For air traffic management, still people use this. This is a more powerful language for real-time applications. So this is all about from my side. We'll discuss about all these questions in the next class. Before that, I want you to prepare for these questions to answer in the next session. So this assignment questions also, I'll post it in WhatsApp again. This is available on my blogger also. If you go to, I have shown you my blogger, right? My website. So visit my channel and my website. You will find everything. Go to my website. You can find PP lecture notes. Here you can find 2021 assignments, which I wanted to discuss tomorrow. In the next class, I'll be discussing these questions. Okay, you download from here. Got it. And go to my channel and subscribe my channel. Listen all this video. Prepare for the 2 units to answer the questions that I'm going to rather discuss tomorrow. Fine. Is that clear to all of you?
Yes, sir.
Yes. So we'll stop our class here. If you have